In the last lecture, we looked at TCP scan, and we were able to code the TCP scan in our port scanner tool that we started scripting. So in this lecture, we are going to take a look at the another type of scanning called the still scan, which is also called the scene scan. So scene scan is also somehow similar to the TCP connect scan, but with just some minor differences. So in the first step, the client sent a packet, a scene packet, over the a particular port that it wishes to communicate with the server. Now, say it wishes to communicate with the server over port 80. Now, it's going to send a scene packet to the server over port 80. Now, if that particular port is open on the server, then the server is going to respond with a packet containing a scene and acknowledgement flag back to the client. Then the client will now reply back with a packet containing a reset flag. So that is the only difference. The client terminate the connection with a packet containing a reset flag, unlike the TCP full connect scan, where the client terminate the connection with a packet containing both a reset flag and an acknowledgement flag. So the only difference is that the client terminate the connection in a still scan using a packet that contains only the reset flag, and then we can come to the conclusion that that particular port is often on the server. However, when the client send a packet over a scene packet over a particular port that wishes to communicate with the server, and the server respond with a packet containing a reset flag, then we can come to the conclusion that that particular port is closed. However, when we couldn't get any response from the server, then we can conclude that that response is filtered. That is, there is a firewall that is blocking us from making a connection to the server over that particular port. Armed with this knowledge now, we can translate this into an algorithm of the scene scan. So in the first instance, we have in the first step, we send a scene packet to the host computer, to the computer that we want to perform the scene scan on. We send a scene packet, and then if the response is scene arc, then we send a reset packet, and then we print that the port is open. And then otherwise, if the response is reset, is a packet containing reset flag, then we conclude that that particular port is closed on the server. And if we couldn't get a response, then we come to the conclusion that that particular port is filtered. So now we are going to make use of this algorithm, and then create a function that will perform a scene scan using our port scanner. So now we'll move over to the our file where we created the function that perform the TCP scan, and then create any function that will perform a TCP TCP scene scan. All right, so we just come over here and then create a new function. So I'm going to define a new function, scene scan. Alright, so what I'm going to do, so the differences between the TCP connect scan and scene scan is not all that much. All I have to do, I'll just come over here, copy the code here, and then just paste it, and then make the little changes. So I'll just come over here, copy this, and then I'll come to the scene scan, and then I'm going to just paste it. Alright, to save time. So I'll just go over. So we have the source port in line number 93. We generated a number using runshot class runshot. We generate a number for us that will serve as the source port. That is the source port where we'll be sending our packet from. And then we have a line number 4. We have IP scan. We created the IP scan packet, which is basically an object of class IP, which is from module scapy. And then we pass dest in the dest field. In that particular packet, we assign it with the value of the target that we are going to pass whenever we invoke this function. So here we are going to define a target. So whenever we invoke this function, we are going to pass target, and we are also going to pass port. Then in line number 95, we also created a TCP scan packet, which is basically an object of class TCP from module scapy. And then we also initialize the values of the various fields that particular packet contains. So we have in the last lecture, we made use of our method show to show all these fields, and now we are assigning value to those fields. For the source port, we assign it with the value of the source port that we generated line number 93, and then for the destination port, D port, we assign it with the port that we are going to pass as argument whenever we invoke this function. And then for the flag, since we are sending a SYN packet, remember that the first step is to send a SYN packet, so we are assigning the flag as S, which basically stands is a later representation for a SYN packet. And then now we combine the IP scan packet and the TCP scan packet to generate our scan packet that we are actually going to send to the host computer that we wish to perform the scanning on. And then now when we send it using function SR1, which is basically a function that will send the packet and then get us the first response. So we make use of it, and then it is also in Malicious. Now the response that we got, we assign it to variable scan response. Also we define some fields within that particular function method. So we have timeout, we assign it with the value 1, and then also bubbles, we will assign it with the value false because we don't want any unnecessary information. So and then whatsoever response we get from this function method SR1, we assign the value to scan response variable. And then in line number 99, we now actually test to see if we actually got a response from that particular computer. So if we actually got a response, if scan response equals to none, then we test to see if that particular packet has layer scapy.tcp. TCP is a class from Malicious as we have known, and then we make use of the function has layer to now actually check if that packet has this layer within it, scapy.tcp. Now if it has this layer, and then we also now want to check for flags in that particular layer. So now we are checking if scan response within that packet, then that packet is scapy.tcp layer. If scapy.tcp layer has a flag with the value 18, and we have seen that the value 18 corresponds to SE, which is SYN ACK. But in this case, since we are we are still in the also SYN plug, we are expecting a SYN ACK, as we have seen here in step number 2. A response is SYN ACK, so we are checking if the response is SYN ACK. So if the response is SYN ACK, now we are going to create an so this is where the changes that is going to come, as because SYN TCP scan differs from SYN scan. So in in SYN scan, as we have said earlier, we are only going to send a packet containing a reset flag, not unlike the TCP connection, where we have to send a packet containing both the reset and acknowledgement flag. So we are only going to send a reset flag only. So we are going to create an IP packet and the IP reset packet and TCP reset packet, but our TCP reset packet will only contain the reset flag because it is a SYN scan, unlike the TCP connect scan. Then we combine the two of them together to create a reset packet, which is a combination of IP reset packet and TCP reset packet that we created in line number 102 and 103. Now, and then in line number 105, we now actually make use of method SR1, which from Malicious to now actually send the reset packet using a timeout of 1. We are telling it to wait for 1 second. If after 1 second didn't get any response, then move on, continue. And then we set the verbosity parameter to false. We don't want any unnecessary information. And then we return open. So we terminate the connection and then return open. That particular port is open. And also in line number 107, we are going to change it from 20, since we are not expecting a reset ACK plug. We are expecting a reset plug. So we are going to change it from 20 to reset. Reset and reset correspond to decimal value. If you are using the decimal equivalent, which is 4, so we are going to replace it with 4. We are going to replace it with the decimal of 4. So if the TCP flag is 4, then that is reset flag was sent. Then we can conclude that the port is closed, because that corresponds to our algorithm. Because if the port is actually closed, then we are expecting a packet containing a reset flag. So also here, then we can conclude that that particular port is closed. Else, if we couldn't get any response, that means that our response is none. Then we conclude that that particular port is filtered. So these are just the basic differences between the SYN flag and the TCP flag. So in the response, we send in the when we want to terminate the connection, we send a packet containing a reset flag, not a flag containing an ARC flag and a reset flag. So with this, we have successfully have our scene scan, our function scene scan. So we are going to save it, and then we are going to call that particular function and then try to perform fault scanning on it. And then if there's any error, we are going to fix that error. So instead of calling TCP scan, I'm going to invoke scene scan here. So scene scan, and then we are going to print the response. So we'll go over to the terminal and then try to run this script. So I will now, okay, so I'm already in the directory. So I'll just type sudo and then Python 3. And also very important that we cannot perform scene scan on a non-root account. Also, we have to on a non-root account unless we precede it with sudo. So we have to give it admin privileges. We must have admin. We must run the command with root privileges before we can perform a scene scan on any Linux machine. So we have to precede the command with sudo Python 3 and then port scanner, which is the name of our script. And then now we give value for the positional argument, with 10.0 to 15, which is the IP address of the machine that we want to scan. And then the type of scan that we want to perform is scene, and then we specify the port number, and then say we want to scan port 80. So I just hit enter. I'm going to enter the password. All right, so we have our response none. Are we expecting a response none? So that means something is wrong that we have to go and fix, because we are not expecting a response as none. We only have our response has to be either open, close, or filtered. So we need to go and check our code and then fix anything that needs to be fixed. Now, the reason why we're having none as a response, it has to do with the logic behind the algorithm. Even though in the algorithm, what we have here is that we have that if the port is closed, then we are going to have a packet with a reset flag as a response. So and that is also what we have in the map website. This is a map. What we have algorithm for the scene scan. If the port is closed, also this is what we have, that we are going to have a reset a packet will be sent from the computer with a packet with a reset flag. So basically what we have is not only a packet with a reset flag, it is a packet with a reset and acknowledgement flag. That is what we are going to have if the port is closed, not only a packet with a reset flag. So that is why instead of having one of the three responses that we are expecting, either the port is open, is closed, or filtered, we are having none as a response, and that is not what we are actually expecting. So we have to go and modify this our algorithm so that we are going to have reset arc as a response. When we have reset arc as a response, then we know that that particular port is closed. So we are going, basically, if the port is closed, we are going to have reset arc as a response. So I will save it, and then I'll go back and modify our code here. So elif scan response kp.tsp flag is not going to be reset, it's going to be reset arc. And then when we look at the table here, reset arc, as we have seen earlier, we can use decimal equivalent of 20 or hexadecimal equivalent of 14 to represent reset arc. So I'll just go back to our code and then use we are going to use decimal equivalent of 20 to represent it, and then we will run the program and see whether we are going to have a desired output. So I'll save it, and then I will go back and run the program and see. So now we'll run the program again. I'll just make a use of the arrow key to access the last command I ran, and then I'll hit enter, and then let's see what the response is going to be. As we can see, the response is closed. It's closed. And then also we want to we print the packet.summary. We see that we are going to have reset arc as a response, not only a packet with a reset flag. So I can choose to, before returning the option as closed, let us print the packet and see how the packet is, what the response is. So we are expecting scan response. So we are going to print the scan response. So we are going to have print scan response cancel response, and then dot summary. So let's get a summary of the packet and see the plug that is attached within the packet. So I'll have it, and then I'm going to go back again and then print it out. So before it return closed, it's going to actually print out the packet for us. So we go back again and then run it and see what the output is going to be. Okay, as you can see, we have the RA flag, reset ARC flag. So basically, if the port is closed, it's not only reset flag that is being sent, it's a combination of reset and the ARC flag to notify us that that particular port is closed. So we'll go back to our code and then remove the print. We don't need to print it out since we have make use of this, and we have known that it is actually a combination of reset and ARC flag that is being sent, not only a combination of not only a single plug, a single reset plug. Okay, so I can also go to my Windows 10 and then enable the firewall and see whether I'm going to have filtered as a response. And then we have run this command before, that if you want to enable the firewall, then we run the command netsh advanced firewall set all profile state on. So I'm going to set it on now, and then so I've enabled the firewall now. So when we run the scan, we expect to have filtered as a response. So we'll come back here and then run the script again and then see what we are going to have as a response. So I'll hit enter and then see. All right, so I'll spare my password here. And then let's see what we are going to have as our response. Filtered. So as expected, we are seeing that it is filtered because we couldn't get any response. The firewall is blocking our scan. Okay, so also there's a little modification that we need to do. Instead of using the SR1 method to send our packet, since we are only sending a reset packet, we are not expecting any response, we can make use of another method called send. Now send method will now send the packet and will not expect any response. However, set response do not have this particular parameter timeout of cost 1. So we are going to remove it, and then we'll run the program again, and then if there's any issue again, then we can see we can leave our code. Our code is okay as it is. So we'll run the code again, run the port scanner script again, and then see what we are going to have as a response. So perfect, we couldn't get any issue. Okay, so let me go back again, disable the firewall, and then see with the firewall enabled, if our disabled rather, if we couldn't get any issue, then we can conclude that our scan function is working satisfactorily. So we just go back again and then run the code, run the port scanner, and then see what we are going to have as a response. Okay, so we can see close. So I can see we can conclude that our port scanner is now working. Our scene function is working as expected. So in the next lecture, we are going to continue building upon this particular port scanner tool.